All right, question, or MTS, Algebra 1, homework 1.9, questions 7 and 9, okay? And so, I'm going to start with question 7, of course. Right? And I'm looking at this, and it says, prism A is similar to prism B, okay? You guys probably haven't gotten these, you don't know these symbols yet. So, this symbol right here is a similar symbol. We'll be learning that a lot next year in geometry. Okay? But what similar means is that they're proportional. And that's huge. So since we know they're proportional, that means that the ratios are equivalent. Okay? So that means we can do that cross multiplication thing that we were talking about last week. Okay? So the way I like to set this up is, since these are very similar in shape, right? This isn't going, in other words, this isn't looking like this, right? This side is to this side as this side is to that side, right? And I keep this really simple for my geometry students. If they're similar, that means this should equal that, right? Mm-hmm. This ratio, right, should equal this ratio, okay? As long as some number multiplies against this to give me this, okay? So in that aspect, that's all I do. I set it up as 2 over x is equal to 10 over 35. Okay? And now I can do the math. So I come over here.
I'm confused. No, I'm not.
Okay? So, it's okay. A lot of people get confused on these problems, and I think I need to pull back. No, back. There we go. Alright, so 2 over x should equal 10 over 35. Okay? And now I got to do the math. So what would I do to get this? Cross multiply. So it's just this guy here, right? Which would give me 10x. And this guy here, which would give me 2 times 35. What is 2 times 35? So, good. If we don't know, think of it like this. 2 times 30. 60. Right? 2 times 5? 10 and 60? 70. Say no more. Okay? So, it's real simple. If you keep it simple, right? Do your tens first. Then do your ones. Or do your hundreds, then your tens, then your ones. Okay? And I even like to set it up like this. 2 times 30 is 60. And 2 times 5 is 10. And then I've got my 70 set up. Okay? Alright, now what? Divide. What do I get? 7. So that means that x is 7. That this side, to be proportional, this has to be 7. So let me ask you something, real quick, because this is how we would check it, right? So think about it like this. 2 sevenths is proportional to 10 35ths. Is that true? So what times 10 is, or what times 2 is 10? 5. Is 5 times 7 35?
Yeah.
Perfect. Then we're good. See how that works?
Yeah.
There's another way you could solve this problem, but sometimes these numbers aren't as easy as 5, and right? Sometimes they're fractions inside a fraction. So, no problem. We got it. It's easy. All right. Next step. Problem number 9 we wanted to do. So, I'm going to come over here, erase that. Take another picture. Oops. Before I take a picture, Carlos, can I get you to hold this real quick? One more time.
Can I get number
there. Perfect. And ching ching. Thank you. All right. And I'm going to do the other one over here so that I don't erase this. I want you guys to get caught up while I'm getting set up on the camera. Get the camera on the number 9. Right? So, move the camera over here. Everybody at home, they're going crazy because they're like, okay, I just went bonkers. All right, okay, here we go. So number 9. With number 9, we're going to go through it step by step. And I was helping my daughter's friend. He was over, and he was having trouble with story problems. Right? They're in algebra too. So algebra also, I should say. And so they were having trouble with the story problems. All algebra students have problems with story problems, right? So I'm trying to help them out. I'm like, we gotta dissect the equation. We need to figure out what this is saying. So number 9 says a triangle has side lengths of 5 inches, 12 inches, and 15 inches. Well, I thought this was going to be relating to this, and it's not. Right? It's totally different. So I got a triangle. So what I'm going to do is kind of, I want to do something real quick. Okay. I'm going to do this. Okay. So since we don't care about that, let's do this. Boom. And then boom. Perfect. A triangle has side lengths of 5 inches. So that means I have a triangle. I don't care what kind of triangle, I just know it's a triangle, right? And so one side is 5 inches. So, okay, a side is 5. And another side is 12. Okay? This is 12. Okay? We didn't draw it to scale, obviously, right? We just made a triangle and said one side's 5, one side's 12. Okay? And the other side is 15. Okay? Every dimension is multiplied by a 5th. Okay? So I'm going to multiply everything by a 5th. So I'm going to change the color. Let's go with red. I'm going to take this and multiply it by 1/5. I'm going to take this and multiply it by 1/5. I'm going to take this and multiply it by 1/5, right? So every side is multiplied by a 5th. What's my new smaller triangle, right? So this side should go right here, yeah? And that would be how much? 1/5 of 5. I don't even know if that's what it's asking us, but yeah. Okay, so what's 1/5 of 5? Come on, 1/5 of 5. Anybody know we're in trouble? Okay. 1/5 times 5 means 5 over 1, right? So 5 goes into 5 how many times? Once. 1 times 1 is? 1. And 1 divided by 1 is? 1. So that would be 1. Okay. So how many 5s are there in 15? 3. See? A little easier to think of it that way, right? So that would be 3. And then, how many 5s in 12? Oh, that's a little difficult. 2 and
5.
Close.
Oh.
2. So think of it like this. It's basically 12 over 1 times 1 over 5. So that would be 12 times 1 is 12. And 1 times 5 is 5. So 12/5, right? Or we could think of it as, and next year in algebra or geometry, you'll learn these symbols. This is a symbol for or. Okay? Or 5 goes into 12 how many times? 2, right? 2. With how many left over? 2. Yeah, because 2 times 5 is 10. 10 from 12 is 2, right? 2 left over what?
5.
Perfect. So it's basically 5 and 2/5. So if you want to put 2 and 2/5, perfect. 12/5.
I don't get how you did that.
Okay, let's do it again. And another color. So I have 12/5, right? Okay? And so 12 goes, or 5 goes into 12 how many times? Okay, 2, okay? So 2 times 5 is how much? 10. So I take the 10 away from the 12, and how much do I get? 2, right? And that 2 is left over the 5.
So you just turn it into a mixed number.
Exactly. Okay. Take an improper fraction and make a mixed fraction. Perfect. Okay, so what is it asking us though? Sorry, I need to erase this now because I can't see what it's saying. It's saying how is the ratio of the parameters related to the ratio of the corresponding sides? How is the ratio of the parameters related to the ratio of the corresponding sides?
5.
Well, how is it related?
Everything.
Everything is multiplied by the ratio. Okay? Now, let me take it a step further. What if I were to ask you what the perimeter is of the new triangle? Could you tell me? How would you find the perimeter? Add up all the sides. You have to know perimeter in here. Perimeter is adding up all the sides. Area is length times width. We wouldn't be able to find the area. We're not ready for that yet because we don't know what the height is. Okay? We need a lot more geometry to do that. But we can do perimeter. We just add up all of these sides. Almost erased it all. All of these sides. So 1 plus 3 plus 2 is 6. 6 2/3. That would be the perimeter. But as far as the ratio is concerned, the ratio multiplies each side to find the other side. That's it. Does that make sense?
No.
No? Okay. To find the other side of the similar triangle, as long as they're proportional, we're going to use a proportion. That proportion is called a ratio. That ratio, in this case, they gave us is 1/5. Okay? So to find the side of this, I need to multiply each side of the beginning one by that ratio. 1/5 times 5. And I get the new side, which is 1. So the whole key to finding the parameters of the next triangle is multiplying the ratio against the original sides.
Okay, I get it.
Perfect.
You know this